Hello, welcome to Astronautics for Exploit. This is Dr. Ayanshola Ogundele. Smart Grid, a digital technology network and an enabler of Internet of Energy. The focus points of my presentation are as follows: Smart Grid features, Smart Grid renewable energy and Internet of Energy, and Smart Grid technologies. Smart Grid, an intelligent bi-directional electrical power system which enables two-way flow of electricity and data with digital communication technology, is presently receiving high attention due to the enormous advantages it offers to the humankind. As the world population is propelled to reach about 9.7 billion in the year 2050, energy consumption is being given higher priority to meet people's power need. This is leading to high investment in renewable energies to keep pace with the increasing power demand and to develop new technologies such as smart grid. Via Industry 4.0 and using smart grid, there are various revolutionary change in process manufacturing, transportation, and logistics to reduce traffic delays, water management to eliminate losses and improve water usage, augmented packages, and a host of others. Both Industry 4.0 and smart grids have automation, efficient use, optimization, and management as common goals. The Internet of Energy, a combination of energy and internet, is the predecessor of the smart grid, which is aiding easy integration of renewable energy sources into the power transmission and distribution networks. The smart grid, a critical infrastructure for building a clean system, uses Internet of Things to contribute to an efficient and robust energy management solution. The Internet of Things smart grid helps to achieve two-way communication between the connected devices and hardware. Smart cities are adopting smart grid technologies using dedicated networks that connect devices that are distributed to homes and businesses using smart meters, data concentrators, transformers, and sensors. Smart grid. Smart grid, a highly distributed network of clean renewable energy deployed at the edge of the existing grid, is a digitally enabled electrical grid that collects, distributes, and works on the information about the behavior of all suppliers and consumers in order to improve the efficiency, reliability, and sustainability of electricity service. Illustration of the adoption of smart grid technology by the smart cities is shown in this picture. Smart grid incorporates all distributed loads, designing them to look and act like traditional carbon-based loads. In smart grid, energy flows omnidirectionally, both to and from the source of generation, which renewable energy sources require, and the entire system is balanced for intermittent energy sources like solar and wind in real time. Smart grid technology, in reference to the power system, is shown in this picture. Smart grid enables providers to have flexibility to distribute energy where and when it is needed most, while giving customers the information needed to make environmentally conscious and cost-effective energy choices. The picture here shows smart grid structure, transformation of the utilities industries. Smart grid operations and energy measurement. These activities are done via advanced metering infrastructure, smart distribution boards, load control switches, and smart appliances, renewable energy resources, including the capacity to charge packed electric vehicle batteries, energy efficient resources, and sufficient utility grade fiber broadband for connection and monitoring. The picture here shows description of the Internet of Things. In this picture, we have the illustration of smart grid connection on clear power plant, thermal power plant, hydraulic power generation, photovoltaic, renewable energy, wind generator, ecological vehicle, cities and offices, homes and factories. Smart grid features. The different features of smart grid are reliability, flexibility, efficiency, sustainability, market enabling, decentralization of power generation, and demand response support. The smart grid makes use of technologies such as state estimation, and this improves fault detection and allows safe healing of the network without the intervention of technicians. This enables a reliable supply of electricity and reduces vulnerability to natural disasters or attacks. The picture here shows illustration of energy management. Smart grid aims to manage flexibility in the next generation, transmission and distribution infrastructure, flexibility bi-directional energy flow. Smart grid has the capability to handle possible bi-directional energy flows, allowing for distributed generation, such as from photovoltaic panels on building roofs, but also charging to and from the batteries of electric cars, wind turbines, pumped hydroelectric power, the use of fuel cells, and other sources. Characteristics of a traditional system versus the smart grid is shown in this picture. Efficiency. Numerous contributions to the overall improvement of the efficiency of energy infrastructure are anticipated from the deployment of smart grid technology, in particular including demand-side management. For example, turning off air conditioners during short-term spikes in electricity price, reducing the voltage when possible on distribution lines. The picture here shows illustration of smart meters. Sustainability. The improved flexibility of the smart grid permits greater penetration of highly variable renewable energy sources, such as solar power and wind power, even without the addition of energy storage. Renewable electricity. Smart grid technology is a necessary condition for very large amounts of renewable electricity on the grid. For this reason, there's also support for vehicle to grid. Internet of Things in smart grid is shown in this picture. Market enabling is another smart grid feature. Smart grid allows for systematic communication between suppliers and consumers and permits both the suppliers and the consumers to be more flexible and sophisticated in their operational strategies. Market enabling critical loads. Only the critical loads will need to pay the peak energy prices, and consumers will be able to be more strategic in when they use energy. Illustration of smart industry is shown in this picture. Decentralization of power generation. A distributed or decentralized grid system allows the individual user to generate on-site power by employing any appropriate method at his or her discretion. Smart grid provide users with an automated way to reduce their electricity bills by guiding them to use low-priority electronic devices when rates are lower. Interrelationship between smart power grid, future internet, and current power grid communication network is shown in this picture. Smart grid, renewable energy, and Internet of Energy. Smart grid aids easy integration of renewable energy sources into the power transmission and distribution networks. Electrification process in many countries is stagnant due to the economic unviability of grid extension to remote locations. Electrification of such remote locations can be done by deploying microgrid networks with renewable energy systems. Illustration of space-based solar power system is shown in this picture. Data gathering. The relationship between the smart grid and renewable energy revolves around gathering data. For example, wind farms use mechanical gears that require each link to support multiple sensors. Each sensor is able to note current climate and environmental conditions. This information is then quickly sent through the grid to allow the utility of any issues, which improves both the quality of service and safety. The picture here shows an artist's impression of space solar power system. Electricity usage reduction. Smart grids equipped with parts made from semiconductor material reduce the usage of electricity. For example, electric vehicles can charge at night, a time when offices and homes are not typically using much electricity. Light switches and furnaces can also automatically power on and off. In this way, energy usage becomes smart by not using more than what is needed. Internet of Things and Internet of Energy is shown in this picture. Energy Internet. Energy Internet is a technological combination of energy and the Internet, which is the predecessor of the smart grid concept. Smart grid is an enabler of Internet of Energy. It is an important dimension of the modern electricity system. Interrelationship between smart power grid, future Internet, and current power grid communication network is shown in this picture. Smart grid technologies. In order to better manage power generation, transmission and distribution, and empower customers with real-time control, smart grid uses different forms of technologies and communication networks. The smart grid integrates and manages renewable energy sources effectively using advanced technology. The picture here shows illustration of smart home. The bulk of smart grid technologies are already used in other applications, such as manufacturing and telecommunications, and are being adapted for use in grid operations. Smart grid is about improved generation and energy delivery based on just-on-time demand. It is about informed consumption via energy efficiency to reduce environmental impact and mitigate climate change. The picture here shows illustration of a smart home with home area network. The major smart grid technologies are smart power generation using advanced components, smart meters, integrated communications, power system automation, vehicle to grid, big data, non-intrusive load monitoring, and distributed energy resources. Internet of Things and Internet of Energy are shown in this picture. Smart power generation using advanced components. Smart power generation is a concept of matching electricity generation with demand using multiple identical generators, which can start, stop, and operate efficiently at chosen load, independently of the others, making them suitable for baseload and peaking power generation. Matching supply and demand, called load balancing, is essential for a stable and reliable supply of electricity. The picture here shows illustration of Internet of Energy. Smart meters. A smart meter is an electronic device that records information such as consumption of electric energy, voltage levels, current, and power factor. Smart meters communication. Smart meters communicate the information to the consumer for greater clarity of consumption behavior and electricity suppliers for system monitoring and customer billing. An analysis of smart grid development is shown in this picture. Integrated communications. Integrated communications allow for real-time control, information, and data exchange to optimize system reliability, asset utilization, and security. Power system automation enables rapid diagnosis and precise solutions to specific grid disruptions or outages. Using artificial intelligence programming techniques, the Fujian power grid in China created a wide area protection system which is rapidly able to accurately calculate a control strategy and execute it. The picture here shows global energy transition. Smart grid technologies, vehicle to grid, also known as vehicle grid integration, vehicle to grid technology, transfers unused power from a vehicle into the smart grid. An electric vehicle battery is a cost-efficient form of energy storage. Without smart grid big data analytics, it is impractical to access petabytes of data produced by smart grid devices. Big data captures and analyzes unstructured data from different endpoints in a smart grid. The picture here shows smart grid and how it is enabled by Internet of Things. Non-intrusive load monitoring. Non-intrusive load monitoring or non-intrusive appliance load monitoring identifies the individual energy consumption of households and industrial facilities. Furthermore, consumers can schedule the most cost-effective time to use energy-intensive appliances and monitor and manage energy expenses according to the power consumption. Smart grid and renewable energy are shown in this picture. Distributed energy resources. Distributed energy resources provide energy and enhance local reliability while improving grid stability and on-site fuel utilization. It includes electric vehicles, solar panels, small natural gas power generators, and controllable loads. Recent advances in smart grid is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Smart Grid, a digital technology network and an enabler of Internet of Energy, presented by Dr. Anyashola Ogundele, with the focus points smart grid futures, smart grid renewable energy and Internet of Energy, and smart grid technologies. Thank you.